Iron ore tailing are generated in huge volume from mining and beneficiation operation, and they usually end up as a waste material. Instead of letting them accumulate and cause environmental issue, they can convert it into sustainable construction material through geopolymerization. However, some challenges exist like their low inherent reactivity since they mainly contain hematite and siliceous component. The high water demand and even the interface of hard water during curing. So our objective is to improve the mix design and to see what will be the our curing approach so that we can achieve high strength geopolymers efficiently, remove excess water and ensure long term durability. So now coming to get the best performance out of iron ore tailing, particle size reduction is very important. And in earlier discussion also we come across that we must have to see the band of that 40-45 micron where more than 75 micron should not be there and less than that ultrafine band should be also not present. So grinding the material to less than 40 micron increases its surface area and makes it very reactive. So adding highly reactive material such as metakaolin, as discussed so many places, which also help because it supplies extra aluminosilicate to drive geopolymer gel formation. It helps magnificently. The water to solid ratio is another critical factor that is also being shared in earlier presentations. So too much free water create drying issue and reduces the strength, as we know from the earlier discussion also. By increasing the binder content above 30% and keeping water balance, we can ensure better strength development and easier removal of water during curing. Now coming to the chemical activation and hard water management, which is supposed to be pivotal role in geopolymerization of iron ore tailing. The activation steps uh, is the heart of geopolymerization using alkali activator like sodium hydroxide and sodium silicate. So these activator can break down aluminosilicate and rapidly start the gel formation process. But the proportion of the activators are very important, which is to be timely decide. And if not controlled, the polymer structure may become weak or inconsistent. So this activator participation in geopolymerization of iron ore tailing is very important, and how much this activator is to be blend with the iron ore tailing is also a very important decision. Now coming to another issue, which is hard water. The calcium and magnesium ion from the hard water can interface with the matrix and reduce binding efficiency. So solution include pre-treating the water or blending tailing with the ground granulated blast furnace slag or calcium bearing sources which create more stable gel are very helpful. So by carefully controlling these steps, we achieve faster and stronger polymerization. Now coming to the curing resin and water drive off, which is also a challenging aspect in geopolymerization. Curing plays a dual role. It accelerates the geopolymerization reaction and helps drive off water. So thermal curing in the range of 60 to 90 Celsius significantly enhance this both activity. this both activity. So it accelerates the geopolymer reaction and also drive off water. So this approach prevent access shrinkage and reduce cracking risk. So a stepwise curing process is often the most effective, starting with a thermal phase to remove water quickly and then switching to ambient curing to gradually strengthen the structure. So by 7 days, the compressive strength in the range of 7 to 10 MPa are achievable. With proper curing continued up to 28 days, much higher strength can be realized. Now, at the microscopic level, curing and mix design dictate how dense and cohesive the geopolymer gel becomes. When finer tailing particle and proper curing condition are used, a denser amorphous aluminosilicate structure form. One big factor is water removal. Trapped water create micro void and micro crack that weakens the material. Effective drying ensure that pores are minimized and geopolymer gel form a cohesive, very cohesive network. Techniques like X-ray diffraction and FTIR confirm the presence of these gel phases and directly connect them to improve compressive strength and durability. Now, to ensure success in practical applications, a few recommendations stand out. First, grind tailing finely and blend them with a highly reactive binder like metakaolin or slag. Second, control types and concentrations of alkali activator to match the tailing composition. And third, apply a combination of thermal curing at 60 to 80 degrees Celsius for about 24 hours, followed by a period of ambient curing for strength growth. This strict monitoring of water content is very essential, and it is also contributing a lot on the quality of geopolymer. Too much water not only lowers the strength but also create surface efflorescence which affect durability. So together these measures support sustainable construction practices and circular use of mining waste. So, conclusion and in conclusion, we can say that high strength geopolymer with compressive strength above 14 MPa at 28 days can be achieved with the iron ore tailing provided we optimize mix design, carefully select activators and implement a stepwise curing strategy. The key enabler is efficient water management, driving off excess moisture while preventing microcracking ensure durability. By also addressing challenges such as hard water, we can create a scalable solution that replace the traditional cement system. Looking ahead, these advances not only reduce the environmental burden but also support the circular economy and greener construction industries world.